As I've helped now hundreds of people pick up Devise, I've noticed that having just a basic knowledge of how the web works has allowed people to pick up Devise 10 times faster than they otherwise would. So in this video, I'm going to walk through the basics of how the web works. I'm going to fill in a bunch of holes that you might have on some technical concepts. And I'm going to give you a solid foundation so that you can pick up Devise much faster than you otherwise would. This is not going to be a computer science course. This is not for coders. You don't need to be technical. Let's get into it. Let me just start by saying that I'm not going to cover every single nook and cranny or every detail that I could cover when talking about how the web works. If you do have a big background in computer science, you're going to recognize that I've simplified a lot of things here. This is not about trying to cover every detail. Again, this isn't a computer science course. This is just about us getting a solid foundation so we have some intuition about what's going on here. Let's start with what we all know, which is the web browser, I'm actually even sharing a web browser. I'm using this to make this video. We've all had the experience of going to a URL, typing google.com, hitting enter, and then you show up here and you see a screen that looks like this with Google. So what happened? The first thing you need to understand is the request response model. Now those words request and response might be intuitive to some of you, it might not be intuitive to others. All we mean is that when you hit enter, the browser made a request to the server did some stuff, and then it sent a response back. It's like playing catch, right? The browser, when you type google.com, the browser threw a ball over to the server caught it, and then it sent it right back. And the way that we make these requests are a protocol called HTTP. Again, I'm not going to go into all the details of what that means, but just think about it like a game of catch, like you're throwing a ball over to the server. And when I typed in google.com, the server knew how to handle that. Oh, okay, Google, I need to show this page. But look at this URL that Figma has. There's all these paths in here. When I'm going to hit enter, and this is going to take a second to load. When this ball got sent to the server, Figma looked at all these different parts of the URL and it helped tell it, oh, what app is this person looking at? What are they trying to show? What do I need to return? And it's going to then send that response back to the browser. And specifically, what it's going to send back, what the browser knows how to speak. So we're going to get into the concept of computer languages. So what the browser knows how to quote unquote speak is HTML, CSS, and JavaScript. Just those languages or those type of content. Okay, so HTML is just like a markup language. CSS is how you style HTML. And then JavaScript is a real programming language that you'll use to actually make things interactive. But again, that is all the browser knows how to speak. So if you've heard about all these other programming languages, those are all languages primarily used on your server. Your server could be written in lots of languages. You can use JavaScript just like you use in the browser, with the most popular one being Node, but you can also use Python, Rust, Go, all kinds of languages you could write a server in. So again, I'm going to have my browser. It's going to send a request to the server. So think about this, again, the page I'm looking at right here in Figma. The server looked at the URL, saw that there was some ID, and it knew that this is some Figma Jamboard. The server then is going to go do a bunch of stuff. The server is what connects to your database. So your browser does not connect to a database directly. It always has to go through a server. There are lots of cool tools today, and Devise is one of them, where you can act like you're talking to your database directly. Like in Devise, you can use an action to just create a new row in the database, or you can use an action to load a list of users. Those actions are all still going through a server, which is connecting to our database. Devise just does some magic to make it seem like there was no server in between when you were talking to your database directly, but in reality, that's still what's going on. So the browser sends a request to your server. The browser is what we sometimes call your front end, and your server and your database, this is all what we call your back end, because the front end is what people see, the back end is what people don't see. And the server can do really anything it needs to do. It can look up data from the database. It can write HTML. It can reformat an image. It can do all kinds of anything that you want a computer can do that is going to primarily happen on your server. Okay, so then let's talk about databases. Some databases you may have heard of: Postgres, MySQL, Firestore, MongoDB. And some of you are thinking, what about my database is Supabase? Supabase is a Postgres database and a server that handles connections for you. What Supabase did was take a bunch of common pieces that you often need to run a backend, and they packaged them all together and made them all work nicely together so that you can focus on building a front end and your back end is taken care of for you. Devise does the exact same thing, but we also give you a tool to build your front end, and we give you tools to build your back end. You may have seen the word backend workflow in Devise. We give you a database. Hint, it's a Postgres database that is powering your Devise app. And then we add a whole bunch of magic to make all of these three different pieces work together nice and tidy. Okay, so that's the request response kind of model. Again, when you type in a URL, it's just throwing a ball over to the server and saying, hey, this is what I want to get. This is the URL I want. And the server is going to know, it has all of the logic defined to know what it should do. It can talk to a database if it needs to. And then after the database can return stuff, it can finish processing, and then it's going to throw the ball back. And the browser knows how to take the HTML, CSS, and JavaScript that it gets sent back and how to turn that into an app that you actually use and can interact with, or a website. Okay, so let's talk about these requests. There are more requests than you'd often use in a browser. If I were to put a URL into this text box up here, that would most often be making a GET request. So when you're working with APIs, there's actually more than just GET, meaning I'm going to get data. You may have come across these words like POST and PUT. These are all different request methods that can be made. When I think about an app like Facebook, I type in facebook.com and I see Facebook. But when I want to make a new post and I go and type some text into a post and then I hit submit, that is going to send another request to the server. But this time it's going to be at, just to keep our analogy alive, that's going to be at like /host. And because this word post, think about like mail post. It's like I'm sending something that has a bunch of data with it, and I want you to create a new post. Or the example I was using earlier was for say you're building an app that keeps tracks of books you've read. So I'm sending a post request to make a new book. And then you can use a put request to update a specific book. The point is not necessarily for you to remember about these get, post, and put requests, but it's just the point for you to understand is that these different methods help tell the server what the user wants to do. So I could go to the same URL, like I could do a get request at books, and I can make a post request to books. And the server knows that if a get request, I want to return the list of books. And if I do a post request to books, then I want to create a new book to my list. Hopefully that makes sense. So then the final question that we get asked a lot is, how does the browser keep track of the user? Can I log into X, or I log into Facebook, or I log into Airbnb, and then I reload my page like I just did earlier here in Figma? How did the browser know that I was here? Introducing cookies. Okay, so cookies are not the only way that a user can be kept track of, but the principles will be the same no matter what you do. So we're going to talk about cookies for a bit. All right, so when a request gets made to the server, sometimes you don't send any data with it. Sometimes you can send data, like if I want to make a new book, I can send, hey, here's the title of the book, and here's the description, and here's who the author is. You can send data with it. But you can also send metadata, which is information that is not necessarily tied directly to the request, but the server still needs to know. One of those things that you can send are cookies. So when you click login button to log into Instagram, that's going to send a request to the server, and the server is going to reply with a response, and the response is going to have what's called a header. Think about a header like the header of a document that you'd write in school, right? It doesn't have the actual content of the paper that you're writing. It has metadata about maybe what the title is, about what class you are on, what page you're in. So responses coming from a server and requests to can have headers. And one of them is a cookie header. So the server, after you enter your email and password and click login, the server can respond with a header that says, hey, browser, I want you to save this cookie. And all the browsers know how to look for these headers. And if the server sends a cookie, say, okay, great, I will just save that locally. And then every single time that the browser sends a request to that server, it will include that cookie with it. It doesn't matter what kind of request you're making. It'll just include the cookie as a header saying, hey, here's the cookie that you told me to store. And so that's how we keep track of the user. So if I logged in as Riley Randall 22 from my account, X is going to reply with a cookie and say, hey, browser, yep, that user's logged in. Like store that the logged in user is Riley Randall 22. It's not actually giving my username. It's going to use some unique value, but you get the idea. And so then every single thing I do from then on out in X is going to have this cookie attached to the request. All right. So I know that might have felt like we went quick, but again, the point here was not to cover every single detail. It was hopefully to give you some more intuition about what's actually happening when you use a website and about how the web works, and a few technical concepts that will help you as you start picking up Devise.